Hello, how are you? I hope you good. I am Nafiz Kiani. You watching my YouTube channel. Today I explain what is local dimming in LED, how local dimming work in display. Let's the start topic. Local dimming in LED light-emitting diode displays is a technology that enhances the contrast and improves the black levels of the screen by selectively controlling the brightness of different sections or zones of the backlight behind the display panel. This is done to create more accurate and dynamic lighting conditions for different parts of an image, resulting in better overall picture quality. LED displays are made up of thousands of tiny LED lights that emit light to illuminate the screen. In a standard LED display, the entire screen is lit uniformly, which can lead to limitations in how well dark and bright parts of an image are displayed simultaneously. Local dimming aims to address this limitation by allowing specific areas of the screen to be brightened or dimmed independently, which in turn improves contrast and detail in both bright and dark scenes. There are different levels of local dimming technology. 1. Full array local dimming FALD. This method involves placing an array of LEDs behind the entire display panel. These LEDs are grouped into zones, each of which can be controlled individually. When a scene contains both dark and bright areas, the LEDs in the dark areas can be dimmed or turned off entirely, while the LEDs in the bright areas remain lit. This contrast adjustment provides deeper blacks and brighter whites within the same frame, enhancing overall image quality. 2. Edge-lit local dimming. In this approach, LEDs are placed along the edges of the display rather than behind the entire panel. A light guide or diffuser is used to distribute the light across the screen. While this method is less effective than FALD, it still allows for some degree of dimming. In localized regions, improving contrast to some extent, the effectiveness of local dimming depends on factors such as the number of zones, the precision of the dimming control, and the quality of the display's hardware and software. Advanced local dimming implementations can minimize issues like haloing, a glowing effect around bright objects on dark backgrounds, and blooming light spillage into adjacent areas. Local dimming technology is particularly valuable for improving the viewing experience in content with a wide range of brightness levels, such as movies and games. It enhances the realism of the images by providing better control over lighting, resulting in more vivid and immersive visuals. Now I explain how local dimming works. Local dimming works by controlling the brightness of individual zones of LEDs light-emitting diodes behind an LED or LCD display, which in turn improves contrast and black levels in different parts of an image. Here's a more detailed explanation of how local dimming technology functions. 1. Zone control. In LED displays equipped with local dimming, the backlight is divided into multiple zones. These zones are groups of LEDs that can be controlled independently. The number of zones varies depending on the quality and size of the display. A higher number of zones generally leads to more precise control over brightness levels. 2. Dynamic adjustments. As content is displayed on the screen, the local dimming technology constantly analyzes the image to identify areas that are darker or brighter. For example, in a scene with a bright object against a dark background, the local dimming algorithm detects the contrast between these areas. 3. Selective dimming. Based on the analysis, the technology selectively dims or brightens specific zones of LEDs. For dark areas of the image, the LEDs in those zones are dimmed or turned off, resulting in deeper blacks and improved contrast. Bright areas are illuminated with higher intensity by brightening the corresponding zones. 4. Zone interaction. One challenge in local dimming is preventing unwanted effects such as haloing or blooming. Haloing is the appearance of a glowing ring around bright objects on a dark background, while blooming is the spillage of light from bright areas into adjacent dark areas. To mitigate these effects, sophisticated algorithms control how adjacent zones interact, ensuring that the dimming transitions are smooth and seamless. 5. Real-time adjustments. Local dimming is not a static process. It operates in real time, continuously analyzing the content being displayed and adjusting the brightness of zones accordingly. This dynamic adjustment enhances the viewing experience by delivering optimal contrast and picture quality for different scenes. 6. User control. Some displays allow users to adjust the intensity of local dimming or even turn it off if desired. This can be useful in scenarios where the default settings might not align with personal preferences or the characteristics of the content being viewed. In summary, local dimming technology enhances image quality by allowing precise control over the brightness of individual zones of LEDs. This dynamic adjustment improves contrast, black levels, and overall picture quality, resulting in a more immersive viewing experience, especially in scenes with varying levels of brightness. Now I explain how local dimming work in LED display. Certainly, let's delve into the comprehensive workings of local dimming in LED TVs. 1. Backlight zones. LED TVs equipped with local dimming feature an array of LEDs placed behind the display panel. These LEDs are grouped into zones, which can range from a few to several hundred, depending on the TV's quality and size. 2. Content analysis. When you watch content on the TV, a processing engine analyzes the image in real time to identify areas of varying brightness. For instance, a scene might have a brightly lit object against a dark background. 3. Dynamic control. Based on the analysis, the local dimming algorithm dynamically adjusts the brightness of the individual zones. For dark areas of the image, the algorithm dims or even turns off the LEDs in those zones, which enhances the perception of deep blacks and improves contrast. 4. Brightness enhancement. Conversely, for brighter areas of the image, the algorithm increases the brightness of the corresponding LED zones. This ensures that the bright portions of the image are displayed with greater intensity. 5. Zone interaction. To prevent undesirable effects like haloing and blooming, the local dimming algorithm takes into account the interaction between adjacent zones. It ensures that the transition between dimmed and bright zones is smooth, avoiding abrupt shifts in brightness. 6. Fine-tuned algorithms. Manufacturers often employ advanced algorithms that consider the TV's specific hardware capabilities and the characteristics of the display panel. These algorithms help optimize the local dimming process for the best possible picture quality. 7. Dimming levels. Some LED TVs offer different levels of local dimming, such as high, medium, or low. These settings adjust the aggressiveness of the dimming process, which can affect how well the TV balances contrast enhancement with potential artifacts. 8. Dimming modes. There are a few common local dimming modes. Frame dimming. This basic mode applies the same dimming level to the entire screen. While it can help improve contrast, it might not be as precise as other methods. Direct local dimming. This mode allows for more specific control by adjusting individual zones of LEDs. It can provide better contrast but might require more advanced hardware. Global local dimming. In this mode, the entire array of LEDs dims or brightens as a whole. While it can improve contrast, it may not be as effective as direct local dimming for maintaining precise control. Local dimming technology varies across TV models and brands. High-end TVs tend to have more advanced local dimming capabilities with a higher number of zones, resulting in superior picture quality and reduced artifacts. However, the effectiveness of local dimming can still depend on factors like the TV's implementation, the quality of the algorithm, and the viewer's preferences. In summary, local dimming in LED TVs enhances picture quality by dynamically adjusting the brightness of individual LED zones. This technology results in better contrast, improved black levels, and a more immersive viewing experience, especially during scenes with varying brightness levels.
Let me know how you liked my video in the comments section below. If you like my topic, like the video, share it. Subscribe to the channel and press the bell icon so that the new updates can reach you. See you in the next video with a new topic. Allah Hafiz. Thanks for watching.